For us, zonal controllers really is a great example of scalable architecture. Now, the pain point was initially felt at those high-contented vehicles with huge wiring harnesses, a ton of complexity. You break the car into zones that make them much more manageable from an interconnect, from a harnessing, and also from a up integration of software into a central zonal controller. What we found is as you scale down content, you scale down the zonal architecture. That approach allows you to maintain a common software architecture even across all of those different segments. That's the power of zonal architecture. It brings value really to every segment of the vehicle lineup.
What we've done this year is we've established the fundamental technological building blocks to enable and bring up the platform. We focused very heavily on zone control, and now this year we plan to migrate from zone control all the way up to the high performance compute to have a holistic solution for SVA. At its lowest level, it manages the power in the zone. You can stop there, and the zones across the vehicle. Second, it manages the data or the input-output. That by itself is a freestanding feature. And finally, you can use it as an integration platform. So one could pick either one of the three, two of the three, or all of the three, thus creating not three versions, but actually an entire comprehensive family of solutions.
For all OEMs which we worked with so far, we started first a study to look into their current architecture and to outline a further optimized step, which then would reduce complexity in the number of boxes and also to optimize the software harness. So the study has to come always first in order to address the optimized architecture. So all of the zone controllers will look a little different because the number of IOs, the needs for current are different on all areas of the zones, but they all share the same elements. So they have a microcontroller, which is the same in all of them. They will have an Ethernet switch to up-integrate the Ethernet data, and they will have smart fuses, but the number and the size of the fuses will vary, and also the number of IOs in the zones.
We have several benefits from smart fusing. The most important is the diagnostics, which we need from level 3 onwards if we are talking about automated driving. And the other one is the enhanced energy management. Yeah? So we can reduce here the energy consumption of the complete system, which allows us to reduce here the design size of the battery and the alternator if we are talking about an integrated combustion engine, or we can increase the range of a battery electrical vehicle. We have a complete diagnostics capability of the system, so we can inform the driver early enough that the failure will occur so that he can go to a service station. And if we are talking about automated driving level 3 and above, so we need the diagnostics anyhow. The complexity of a harness became more and more critical over the last decades because more and more comfort and safety features were introduced to the car. And these harnesses, so-called KSK harnesses, are going from the headlamps to the rear lamps and connecting to everything. If we have this zonal approach, we cut the complete topology of a car in several zones and we can produce the harnesses only for the zones. Because we cut the topology of the car in more segments, we reduce these big harnesses going from the headlamp to the rear lamp with wire length up to 10 meters in smaller sections where the average wire length is below 2.5 meters.